Okay, let's start with some real basic ones. Okay, so if you had a mapping notation with finite numbers here, like 1, 2, 3, and let's say this function here did 5, 6, -1, and this was the mapping for the function. Okay, so this is what the function did. Draw the inverse. What would that do? Okay, so this is the domain, this is the range. What would happen is that the domain now will be the range from the original function for the inverse. So we'll get 5, 6, -1 in here. And we would have to map that to 1, 2, -1. So this would be the inverse. This can also be written as a set of points. So this here represents, okay, so we say the function represents here 1, 5, 2, 6, and 3, -1. Okay, this is the original function. The inverse function then will be 5, 1, right, 6, 2, and -1. I meant 3 there, right? -1 gets mapped to 3. Okay, so it's literally just switching. Notice that we're switching the domain and range. So that goes there as a domain for the inverse. That domain becomes the range for the inverse. Okay, this is the purpose of the inverse function, just reversing the process. Okay. All right, so that's for set of points. In the next few videos, let's go back into analyzing the actual functions. We'll start with really easy one, linear, and then we'll move up, quadratic, and so on. Okay, I'll see you there.